Welcome you all for the discussion of discrete probability distribution. In the last video, we discussed what you mean by a random variable, then discrete random variable and continuous random variable and some problems on that. In this video, we are going to discuss discrete probability distribution. So this a discrete probability distribution, that means a probability distribution where x will be a discrete random variable. It is of the form x comma p of x, where p of x is a probability function. p of x probability function ಆಗಿರಬೇಕು ಅಂದ್ರೆ ಎರಡು ಕಂಡೀಷನ್ ಹೇಳಿದ್ವಲ್ಲ ಅದು ಸ್ಯಾಟಿಸ್ಫೈ ಆಗಬೇಕು ಮತ್ತೆ x discrete random variable ಆಗಿರಬೇಕು. ಇದು ಕಂಟಿನ್ಯೂಸ್ random variable ಆಗಿದ್ರೆ ಈ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಕಂಟಿನ್ಯೂಸ್ probability distribution ಆಗುತ್ತೆ. x discrete random variable ಆಗಿದ್ರೆ ಕರೆಸ್ಪಾಂಡಿಂಗ್ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ discrete probability distribution ಆಗುತ್ತೆ. ಈ ವಿಡಿಯೋದಲ್ಲಿ ಈಗ ನಾವು discrete probability distribution ನ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಂಡಿದ್ದೀವಿ. Again, this is classified into two types. One is binomial distribution and another one is Poisson distribution. In this video, we'll just concentrate on binomial distribution. Okay. Now, suppose small p stands for number of success. Number of success in the sense number of events happening. Possibility of the event happening. ಸಕ್ಸಸ್ ಅಂತಂದ್ರೆ ಯಾವಾಗಲೂ ಸಕ್ಸಸ್ ಅಂತಾನೆ ಟ್ರೀಟ್ ಮಾಡೋಕ್ಕಾಗಲ್ಲ. ಆ ಪರ್ಟಿಕ್ಯುಲರ್ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ ಏನು ಈವೆಂಟ್ ಆಗ್ತಾ ಇದೆ ಆ ಈವೆಂಟ್ ಅನ್ನ ನಾವು ಸಕ್ಸಸ್ ಅಂತ ಟ್ರೀಟ್ ಮಾಡ್ಕೋಬೇಕು. ಕೆಲವು ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ ಪಾಸಿಬಿಲಿಟಿ ಆಫ್ ಬೀಯಿಂಗ್ ಡಿಫೆಕ್ಟಿವ್ ಅಂತಂದಾಗ ಸಕ್ಸಸ್ ಅಂತಂದ್ರೆ ಡಿಫೆಕ್ಟಿವ್ ಆಗಿರೋವಂಥದ್ದು ಆ ರೀತಿ ಮೈಂಡ್ ಬರಬೇಕು. ಓಕೆ, ದೆನ್ ಇಫ್ ಪಿ ಸ್ಟ್ಯಾಂಡ್ಸ್ ಫಾರ್ ನಂಬರ್ ಆಫ್ ಸಕ್ಸಸ್, ದೆನ್ ಕ್ಯೂ ವಿಲ್ ಬಿ ನಂಬರ್ ಆಫ್ ಫೇಲ್ಯೂರ್ಸ್. It stands for number of failures. Observe that always the sum of success and failure should be equal to 1. Right. If P stands for the number of success or possibility of success, you can say number of probability of success, and Q stands for probability of failure, then out of n trials, okay, the x success, probability of x success out of n trials is given by p of x equal to, I'll write here only, p of x equal to ncx p power x q power n minus x. So this is the corresponding probability function for binomial distribution. For Poisson distribution, this definition will be different. P of x will be defined in the different way. Okay, so for binomial distribution, the possibility of getting x success out of n trials is given by p of x equal to ncx p power x into q power n minus x. In general, for discrete probability distribution, the mean mu will be equal to n into p. Mu will be equal to n into p, and variance will be equal to n into p into q. Obviously, standard deviation will be equal to square root of npq. This is true for any discrete probability distribution, whether it is binomial or Poisson. This holds for discrete probability distribution. So keeping these things in mind, let us move on to solve some problems on binomial distribution. So the first problem I am going to consider is this one. When a coin is tossed 4 times, okay, let us have this formula S. First problem, when a coin is tossed 4 times, find the probability of first one exactly one head, and second one is at most 3 heads, at most 3 heads, and third possibility is at least 2 heads. Solution. Okay, here coin is tossed 4 times, so number of trials is 4. P, small p. What is small p? That is the probability of success. So success in the sense here, since we are concentrating on getting head, we have to think of probability of getting head. Success in the sense probability of getting head. So in general, if you consider any fair coin and if you toss it, the probability of getting head is 50 and 50%, and the probability of getting tail is also 50%. So P of H is 1 by 2. For each single trial, probability of getting head is 1 by 2. And obviously probability of not getting head, that is probability of getting tail. Probability of getting tail is Q, that is also equal to 1 by 2. Now by binomial distribution we have P of x equal to NCX, this is the formula, P power x into Q power n minus x. Here number of trials is 4, 4cx, P that is 0.5 whole power x into Q is also 0.5 whole power n minus x, that is 4 minus x. You can call this as equation 1. Now the first possibility, getting exactly one head. P of x stands for getting x success out of n trials. Now I want getting exactly one head, that is getting x equal to 1. So first case is P of x equal to 1. So that is, I have to take x equal to 1 here. 4c1 0.5 whole power 1 into 0.5 whole power 3. So you can check that it will be 0.25. Then second point, P of, say at most 3 8s. At most 3 8s means you have to get maximum of 3 8s. That means you may get 1 8, 0 8 or 2 8. Okay, so here you have to check, even at most 3 8 means you can get 3 8s also. You should not get more than 3 8s. So it is x less than or equal to 3. So it will be P of 0 plus P of 1 plus P of 2 plus P of 3. You can use this formula, substitute x equal to 0 to get P of 0, then take x equal to 1, then take x equal to 2, then take x equal to 3, and then can compute that, you get 0.9375. So this is the possibility of getting at most 3 heads out of n trials. So you can also do this as 1 minus P of x strictly greater than 3. So obviously it will be 1 minus P of 4. You can check in this way also, or you can do like this. Third possibility, that is what is mentioned in the problem statement, possibility of having at least 2 hits, at least 2. You have to have at least 2. That means you can have 2 or 3 or 4. So that is P of x greater than or equal to 2. P of x greater than or equal to 2. That is P of 1 minus P of x strictly less than 2. That is 1 minus of P of 0 plus P of 1. You can check that it will be 0.6875. So this is how we have to solve problems on binomial distribution. So this is the first problem we discussed on binomial distribution. Let us consider one more problem, problem number 2. The probability that a pen manufactured by a factory be defective is 1 by 10. So the probability of pen defective is 1 by 10. So here event probability of success stands for probability of getting defective piece. So this stands for P. So P is 1 by 10. If 12 such pens are manufactured, if 12 pens manufactured, what is the probability of getting exactly 2 defective? Exactly 2 defective. This is the first possibility I have to find. Second possibility, at least 2 are defective. Third possibility, none of them are defective. Solution. So here, as I mentioned already, here small p equal to 1 by 10, or it is 0.1. So q will be 1 minus of that, 0.9. Then n is 12 and p of x will be 12 cx 0.1 whole power x into 0.9 whole power n minus x it is. So it will be n minus x, that is 12 minus x. Now let us call this as equation 1. So first possibility we have to determine is exactly 2 defective, that is p of x equal to 2, that is simply p of 2. So I had to take x equal to 2 here, it is 12c to 0.1 whole power 2 0.9 whole power 10. You can check that it will be 0.2301. Second possibility, at least 2 defective. So number of defective p's should be minimum 3. So it is p of x greater than or equal to 2. We can write this as 1 minus p of x strictly less than 2, right? So it will be 1 minus of p of 0 plus p of 1. So it will be, you can check, 0.341. So the last possibility, no defective, that is p of x equal to 0. You have to take x equal to 0 in equation 1 and you can check it to get 0.2824. This is the possibility of getting no defective. This completes the solution of problem number 2. Now problem number 3, the probability of a person aged 60 years will live up to, person of 60 lives up to 70 is 0.65. What is the probability that out of 10 persons aged 60, what is the probability that out of 10 aged 60, at least 2 of them, at least 7 of them it is, at least 7 of them lives up to 70. Solution. So here the possibility of person aged 60 lives up to 70 is 65. So P is 0.65. So obviously Q is 0.35 and the trial is going to aid on 10 people, so n equal to 10, and we have to find the possibility of at least 7 of them lives up to 70. So let us write the formula for binomial distribution. P of x equal to ncx into p power x into q power n minus x. Now here we need to determine p of at least 7, so that is x greater than or equal to 7, right? It will be p of 7 plus p of 8 plus p of 9 plus p of 10. You can rewrite this formula as p of x equal to 10cx p power x into q power 10 minus x. Call this as equation 1. Now first you can take 7, you get p of 7, then 8, then 9, then 10. Then finally you can check that it will be 0.5138. That will be the required solution. So this completes third problem on binomial distribution. Let us consider the last one on binomial distribution. The number of the number of telephone lines busy at an instant of time is a binomial variate with the probability 0.1. So problem number 4, number of do one thing, possibility of line busy being busy is 0.1. So this is p, so p is 0.1. If 10 lines are chosen, what is the probability that no line is busy? Second one, all lines busy. Point number 3, at least one line busy. And the last one, at most 2 lines busy. Okay, then solution. So here p is 0.1, n is 10, and obviously q is 0.9, and p of x will be 10cx p power, that is 0.1 power x into 0.9 power 10 minus x. Call this as equation 1. Now first possibility, no line busy, that is p of 0, it will be 0.9 whole power 10, so approximately it is 0.3487. Second possibility, all lines busy, so that is I have to take x equal to 10, so it is p of 10, right? So p of 10 will be 0.1 whole power 10. Third possibility, at least one line busy, so it is p of x, number of busy lines should be at least 1, so it may be greater than or equal to 1. So it is obviously 1 minus p of x strictly less than 1. So it is 1 minus p of 0. P of 0 we computed already, 0.3487. So 1 minus 0.3487, it will be approximately 0.6513. The last one, probability of at most 2 lines busy. At most 2. So it is p of 0 plus p of 1 plus p of 2. It will be approximately 0.9298. So this completes the solution of the last one. So with this we have discussed problems on binomial distribution. Next video we shall concentrate on Poisson distribution.